Hi, this is Unit 1, Section 2 Notes for Geometry. I'm going to start off with the distance formula. If we want to know the distance between any 2 points on the coordinate plane, the formula is the square root of the difference in the x's squared plus the difference in the y's squared. All of that is under the square root symbol. So the important things here are that you are grouping the x's, taking the difference in the x's and the difference in the y's. The order that you do that in doesn't matter because those quantities are being added together. But what is important is the placement. Whichever x is first in this difference, its corresponding y needs to go first over here. And whichever x is here, its corresponding y needs to be second in that difference. So if we take a look at, let's just go ahead and roll down to number 2. Number 1, we would need to identify the points, so we'll just roll to number 2. If I want to get the distance between these 2 points, I'm going to go the difference in the x's as -4 minus 3. And then I have to go in the same order from left to right for the y's, so I have to say 1 minus -1. And then it's just simplifying from there. -4 minus 3 is -7. Squared is 49. 1 minus 1 becomes addition for a total of 2. Squared is 4. So we've got the square root of 53. And if you plug that into a calculator, that is approximately 7.3. The midpoint formula is a little less complicated. So if you're trying to find the midpoint or the exact middle of a segment, you're just going to take the x's, add them together, divide by 2. You're going to take the y's, add them together, divide by 2. I'm not even going to put the little subscript 1 and 2's because the order doesn't matter. Add the x's, divide by 2. Add the y's, divide by 2. For example, if these are our points Q and H and I want to find the midpoint of segment GH, I'm going to add the x's, 7 plus 9 divided by 2, and I'm going to add the y's, -5 plus -1 divided by 2. So that's 16 divided by 2, which is 8, and -6 divided by 2, which is -3. Then on the back side, we can actually use the midpoint formula sort of in a backwards way. Like on number 4, it says, find the coordinates of A if M at -1, 2 is the midpoint of segment AB, and B has coordinates at 3, -5. So if we draw a picture, I know this is not oriented correctly, but I just kind of want to get a picture of what's happening here. So I know that M is the midpoint of segment AB, and it's at -1, 2. B has coordinates 3, -5, and I want to find the coordinates of A, which I'm going to call X and Y. So I know the midpoint, -1, 2, came from that formula where I added the X's divided by 2, added the Y's divided by 2. So I'm looking for this X. I know the other X is 3. I'm looking for this y. I know the other y is -5. So -1 came from this expression, and 2 came from that expression. So I'm just going to set up 2 equations and solve them. -1 came from x plus 3 divided by 2. So I'm going to multiply by 2 on both sides and subtract 3. So the x coordinate I'm looking for is -5. And then I'll just go below here. The y coordinate of the midpoint 2 came from this expression, y plus -5, or I'm just going to say y minus 5 divided by 2. Again, I'm going to multiply both sides by 2. And in this case, so the coordinates of the endpoint I'm looking for would be -5, 9. Then the last part of this section, we're going to throw in a little bit of the coordinate plane. So number 1 says, use the coordinates to compute the perimeter and area of each polygon. Remember, perimeter means the distance around, and area basically means how much space the face of the shape is taking up. So for something like letter A here, since everybody's vertical and horizontal, I can just count it out on the grid. So this side is 1, 2, 3, 4, 5 units long. So is the side across from it. This side is 1, 2, 3 units long. So is the side across from it. So I just need to add that together. 5 plus 3 plus 5 plus 3 is 16 units for the perimeter. Then for area, we just need to recall the area of a rectangle comes from the length times the width. So 3 times 5 would be 15. For part B, for the perimeter, I can count this side and this side because they are vertical and horizontal. This is 3. 1, 2, 3, 4, 5, 6. This side is 7. But I'm going to have to use the distance formula to find the length of that side because it's cutting through a bunch of grids and I can't just count it out one by one like I could on the other sides. So this point A is located at -2, -1, and point C is located at 5, 2. So I'm going to find the distance between these 2 points so I know how long this side is. And I'm going to go -2 minus 5 squared, and then in the same order, -1 minus 2 squared. That's -7 squared, which is 49, plus -3 squared, which is 9, and the square root of 58 is approximately 7.6. So now, if I add all the sides together, 3 plus 7 plus 7.6 is 17.6 units for the perimeter. And we're talking about a triangle this time. The area of a triangle is base times height divided by 2. The 3 and the 7 are the base and the height of this triangle because they're perpendicular to each other. So 3 times 7 divided by 2 is 21 divided by 2, which is 10.5. Okay, then this bottom set, numbers 2 and 3, is really just getting us to use the distance formula a bunch more times. I'm going to concentrate on number 2b. So if you notice, again, similar to the last problem, I'm actually going to change the directions here. It says find the area, but I'm going to change it to perimeter. All 3 of the sides of this triangle are slanted, so I can't just count it out. I'm going to have to use the distance formula for all 3 sides. So I'll just start with this side. I'm going to do -2 minus 1 for the x's and -2 minus 3 for the y's. So that's -3 squared, which is 9, plus -5 squared, which is 25, for a total of the square root of 34, which is approximately 5.8. And just trust me that I ran through the distance formula 2 more times. So when I use the distance formula between these 2 points, you should get the square root of 20, which is about 4.5. And for this side, when you run through the distance formula, you should get about 5.1, the square root of 26. So when you add it all together, 5.8 plus 4.5 plus 5.1, the perimeter is 15.4. And then the last problem I'm going to run through is number 4 on the back side. It says triangle ABC has vertices at 6, 5. So that's point A. Point B is at 12, 3. And point C is at 6, 1. So here's my triangle. Oops, I didn't put C in the right spot. Hang on 1 second. There it is. Okay, so we're supposed to be finding the area. In this case, I can count out this side is 4 units long. And remember, the height and the base of the triangle have to be perpendicular to each other. And the height would go right through there, and I can count out 1, 2, 3, 4, 5, 6 units for the height there. So I don't have to worry with the distance formula this time. It's just base times height divided by 2. I was able to count out both of those. That's 24 divided by 2, which is 12.